All right, everybody, welcome to this month's SeaBEC meeting. It's our first time using the Zoom webinar functionality, so we're trying to make sure we work through all the kinks. We think it's going to go well. Everybody will remain muted throughout, but there is a Q&A window. If you have a question, please go ahead and type your questions in there, and we will try and get them all wrapped up at the end of the presentation. As I'm sure most of you know, Seattle Building Enclosure Council is a nonprofit organization that's designed to promote better building design and construction around building envelopes. We have a great board that helps make light work of doing that and putting on these presentations. You can see the boards. I'd like to specifically acknowledge some new board members, Amanda Prott, Clifford Marvin, and Jeremy DeWitt, who have recently joined the board to help with board functionality and with getting ready for our symposium next May. Our next meeting after this one will be the third in the series called Air Leakage and Balanced Ventilation for Affordable Exemplary Multifamily Buildings. And it will be presented by David Reddy of O'Brien 360. On November 19th. It's a midday meeting, 11:30 to 1. And then we are working on our holiday event / fundraiser. We still want to do something this year, despite not being able to get together and have a white elephant gift exchange. So look for further details on that. SeaBEC's research grant will be wrapping up applications on October 29th. But we are excited to offer $2,000 to help facilitate research projects, specifically focused on enclosures and the Northwest. If you are interested, please reach out to Grace Wong or myself, or look to the seabec.org website for more information. A couple of other building enclosure events coming up in the area. The Association for Preservation Technology Northwest was planning a URM symposium in May. It got canceled and rescheduled to a virtual symposium starting 11/3 through 12/9. They're doing a whole series covering many different aspects of unreinforced masonry buildings. CSI Puget Sound has two upcoming meetings highlighted here. Tears from the Field in Costume on 10/22, and then they're doing a Polyguard Physics 202 on 11/18. If you sign up for that one, they'll actually send you a kit of stuff to play with during the meeting. And then IBEC Puget Sound has their annual meeting on 12/3. Now I'd like to introduce Peter from Northwest Partners, who is our sponsor for this meeting. Peter, thanks for sponsoring, and please take it away.
Thanks, Nathan. I appreciate that. My name is Peter Viertaler, and I've been the principal of Northwest Partners for about 15 years. We started with Vapor Shield products, and now we represent Eco Windows and Leading Charge, which Leading Charge is actually car charging, so very different from what we've been doing in the past. Next. Okay, good. Our Vapor Shield projects include Wrap Shield SA. I'm sure a lot of you have seen the orange on buildings around town. So it's our self-adhered product. And then Wrap Shield IT, which is a mechanically fastened product. Still used on a lot of apartment buildings, although we're seeing a transition now to a lot of SA to meet the energy tightness required. Not that IT can't meet it, but SA is just very, very airtight. Next. And then, of course, we have Reveal Shield SA and IT, which is for open joint siding systems. So if you have any siding systems that will reveal or allow UV to come in, that would be the product. And our Vapor Flashing and Liquid Flash are a great window wrap. The Liquid Flash creates a monolithic barrier all around the window, makes it very easy to to seal everything to it, and it's accepts almost all sealants. And we have a new product called Vapro Air Seal. So this is for the air seal around the back of the window, and so it's much less expensive than the other options. So you might want to look at the air seal at the back of the window really takes a lot of sealant. So this could save you 1/3 to 1/2 of the cost of the seal around the back of the window. So ask us about it. And we also rep eco windows, and we've been doing that for about 3 years. We have about 40 projects in place already, and our claim to fame is triple pane. We're able to get triple pane onto projects for a very, very good price. We have vinyl windows. Our windows are tilt and turn, and so European style tilt and turn. We have U values down to 0.16 and STCs up to 46. So we can really do some amazing things on your projects, especially when it comes to energy calcs. In a lot of cases, we've been able to remove insulation on buildings. And because we're saving so much energy, you may not need to put solar on your roof. Not that we don't want you to put solar on the roof, but it might help you meet the budget for that. So. And then we also have aluminum MB70, and we're doing a lot with storefronts on this. So you have a lot of options now on storefronts, a myriad of colors, and a lot of opening ability, so that you can make those storefronts really fantastic, rather than just the same old aluminum closed bronze and aluminum finishes. And last but not least, because we're doing so much to conserve energy now, we're able to use that capacity for car charging, especially for existing buildings. As you save energy, you're able to create more capacity for car charging. And so there are many ways that you can save energy on existing buildings with efficient quiet windows, air barrier technology, LED lighting, low flow fixtures, rooftop solar. And so what we've found in existing buildings is that by making this right here, for example, is a 50-unit building with 100 parking stalls. By changing out lighting to LED, changing the water, improving or reducing the flow of water, retrofitting windows, and putting an air barrier on a building. In a 50-unit building, we were able to achieve an additional 1,300,000 miles of charging capacity in a building by creating a microgrid in that building. So I just want everybody to understand, by saving energy, doing triple pane or double pane windows in buildings, adding insulation, changing out the lighting, we're actually creating more capacity for car charging with the new technologies that are out there. So most buildings will never need to bring in new electricity from the outside because we have so much latent capacity in buildings already. So that's all I have. Please let us know if you have any questions. Email us or give us a call. Thanks.
Thank you, Peter. Thank you very much. Now I will introduce our speakers for this evening. Our topic is low-rise multifamily residential build tight, ventilate right challenges for the Washington State and ASHRAE 62.2, which will be presented by Mike Lubliner of WSU and Dr. Iain Walker of the Lawrence Berkeley National Laboratory. Michael has over 35 years of experience in the renewable energy and conservation field, works for the Washington State Energy Office and the WSU Energy Program down in Olympia. We're excited to have him speaking today. And then we also have Dr. Iain Walker from Lawrence Berkeley National Laboratory, who also has 30 years of experience as a building scientist. And leads the Department of Energy on indoor air quality in homes. So with that, I will, The original plan was for me to hand it over, but now I'm going to just open this other slideshow and we will get Iain started. Iain, I muted you earlier, but should be ready to go.
I think Mike was going to present first, though, right, Mike? Not me.
Oh,
So
I'm sorry. Michael was going to
good to
present first.
hear
Right.
from
Sorry.
me later. I've got lots to say, but we'll let Mike speak first.
I got that backwards. Michael, there you
Can you hear me now?
Yes. Yes, we
Okay,
can hear you now.
Thank you so much for inviting us to speak here. We really appreciate it. SeaBEC's a great organization. We look forward to continuing to engage after this presentation. This is just the first step. I'm going to go through a whole bunch of things today, and I don't expect everybody to absorb them all. We're going to record this, and then we're going to provide some assignments for folks that really want to get into the understanding of the Washington Energy Code and the mechanical codes. And thanks, Walsh, and again, SeaBEC, and my funding source, the Northwest Energy Efficiency Alliance. So next slide, please.
Yeah, and folks, there's a question and answer section in the Zoom, and if you can use that, we will try and get to those questions at the end of the meeting.
Yeah, what we're hoping to do is me give you an overview here, and then on the energy code and value proposition for build tight, ventilate right, get into some of the details of the things we need to come up to speed on, and then hand it over to Iain. I've been working with Iain for many years on ASHRAE 62.2 as a voting member. Iain is now the chairman of 62.2, and we're gonna have some fun today. So the first slide here is my CYA slide. This is the one to let you know that I do not speak for the State Building Code Council, Washington State, or the authorities having jurisdiction. We provide advice based on first principles and our understanding of the code. Sometimes there's requirements and there's questions that we can't answer that we ask that folks get a jurisdiction to sponsor them and get an interpretation. I expect there'll be a number of those coming out of this presentation and the adoption of the energy code here, which is going to be effective on February 1st of next year. Next slide, please. So what we do at the energy program, as far as code support goes, is we provide in-person webinar and video training. The recorded webinar here today with a live webinar converted to a recorded one so that anybody can access it in the future. We provide phone and email inquiries and hotline support. I'll give you the resource so that you can email or call us with your questions. We get 2,000 to 2,500 calls a year. This year it's been way up, and that's Melinda and myself. Energy code compliance tools, we're in the process of developing the new compliance tools. I'm going to demonstrate one here today, or just show and tell it. We're also going to be updating our website, which hasn't been updated since 2015 code. We're going to probably roll that out sometime before the end of the year and give people access to the new code tools that we're rolling out at the same time. We also love and would love to put out the opportunity to get out in the field with building departments and other stakeholders and actually videotape and engage the stakeholders so that we learn what's going on in the real world. And that's really important to the quality assurance part of implementation of the code. The code is just on paper. It's when QA and we get out there and implement the code, that's where the energy savings is. Next slide, please. So spend at least an hour on our webpage. As I said, we handle the residential energy code. So that's single family and low rise, 3-story or less R2 multifamily. And if you want to get hold of us, there's our contact information. Carolyn is our one of our engineers who works on the tool development and backs me up on technical things. And if you have non-residential questions, you need to contact the Evergreen Technology Consulting Center and talk with Lisa and her staff. Next slide, please. So I'm not sure exactly the background of the audience, so I'm just going to go through my top 10 ways to avoid mold. You know, back in the 80s and the 90s, there was $500 million in mold litigation in the Northwest between Vancouver, Seattle, and Portland. We want to make sure, I think, that we don't repeat that problem, which means we really need to understand best practices. So vapor retarders limit moisture condensation. That's why they're in the code. Warm surfaces limit moisture condensation. Insulating on the exterior of a building, CI, those kind of approaches can warm up the surfaces, the condensing surfaces. All you folks that play with WSEC know all this stuff. WSEC is a model for modeling moisture and the impact it may have on your building and your climate with your systems. Obviously, pipe and duct insulation limits condensation, which avoids some of the things you might see on your T-bar ceiling and moisture staining. Water resistive barriers is really what we came to after we had all that mold litigation in the 80s and 90s. And that is to limit bulk moisture and rain from entering into the building enclosures. And what we're going to talk about today is the build tight, ventilate right philosophy, A. I say A because I learned this from the Canadians many, many years ago. And I get this question at least 20 times a week on the hotline. Why do you make us tighten up the building and then ventilate it? Well, it's all about who wants control of the indoor environment, Mother Nature or you. Next slide, please. So how do we avoid these things? What's our best practice? Well, the code requires that we use a blower door to test and provide feedback so we can reduce the envelope leakage. And then if we have ductwork, we locate those ducts within the conditioned space as well as the HVAC system. That has a dramatic impact on your blower door testing. If you have ductwork as well, you have to test it, especially if it's outside the conditioned space. And tools like duct blasters, duct testers allow you to do that. I'll talk about that a little bit more. Design, installation, commissioning, and operation and maintenance to ventilate right. I've made a career about this. It's challenging, we're doing better, and we'll continue to improve. And if you use a systems approach for moisture management, in other words, you understand the interaction between bulk moisture, vapor, ventilation, air sealing. If you understand those, you can reduce your risks associated with mold and indoor air quality issues. Next slide, please. This was shared with me by Dr. George Tsongas from Portland State. It's research, it's basically the fundamentals of, he's been expert witness in quite a few litigations on mold. And this is one example of the way that mold would, or moisture would occur and could condense in a wall. Vapor diffusion. That's why we have vapor retarder requirements in the codes. And then what we find is that the diffusion is not the only way that moisture gets into these assemblies, actually through holes, through switch plates and other things. And that can be, research shown that that can be the #1 reason that your wall gets full of moisture. It's not the diffusion through the drywall, it's the holes. Next slide, please. One of the things that we are going to be doing, WSU, and we've been working with the Air Barrier Association of America. I think Laverne is on the call today. And we will be working with them to roll out a Washington State Energy Code R2. Remember, that's low-rise multifamily. And we want to develop a training and certification programs. It's going to focus on build tight, ventilate right. And we're going to talk about the energy credits and the value proposition for this as an approach to meet the energy code. Training and certification is going to include training the people to install the enclosures correctly to the manufacturer's requirements, and testing the building enclosures to make sure that they pass the blower door test. And we might even make a fact sheet on what the heck do I do when I fail the blower door test. But we really need to be working on this area. R2 multifamily is going to be a challenge, and that's why we're doing this today. So ALBA is going to be a useful partner, and we hope to work with them so that we can let people know that there are trained, certified people out there in the industry that can help. Next slide, please. Other partners and tools that we use, we work with Retrotech and Tech. Those are the two manufacturers that manufacture these blower door and duct testing equipment. and also equipment for measuring and commissioning the mechanical ventilation system, all part of Build Tight, Ventilate Right. If you really want to learn about this stuff, you need to spend 1 to 3 hours at these websites and learn how this equipment works in whatever sector you're looking at, single family, multifamily. They've got a resource. You got to do it. That's what's going to show you. I can teach the class of the fundamentals and the principles, but if you want to learn how the equipment works, please spend some time at quality websites. RED, Residential Energy Dynamics, is a tool for actually helping to calculate what the ventilation rate should be for compliance with various standards like 62.2. Next slide, please. Here's an example, and WSU doesn't endorse any of these manufacturers. We just want to show you all what's out there so you can try it and see if you like it. Red Software, working with Rick Karg, a developer of this. It was really originally developed for low-income weatherization, ventilation, and we have now, it's available in the Red Calc Pro version for compliance with ASHRAE 62/2019. And here's an example of a row house, 1,000 square foot, 2-story row house, 3 occupants with a leakage rate of 400 CFM at 50. And if you go through, this is the input screens. They have some really useful, both web-based and phone-based screens. And if you go to the next slide, this is the input screen. If you go to the next slide to show you the concept here, this would be a triplex looking at 8-foot ceilings. Hit this button a couple times and you'll get all these things coming up. So 1,000 square foot, and then you have the square footage to the other apartments. And this one, we're looking at the middle apartment where there's about 200 square foot. So you have leakage between the apartments, which impacts air quality and odors and things, and has some impact on energy for the interstitial space. But it's the leakage to the exterior of the envelope that's the one that's the energy of energy importance. So here's a kind of an example here of what they use for what they call infiltration credit for a single family calculation. Just show and telling, not explaining this stuff right now, but I would encourage you to play with this software. There is a free version and they have the pro versions as well. Next slide, please. So this would be the printout of that 2-level row home middle unit example. And again, this is the kind of documentation that you can provide to the building official or to the builder so that he can provide it to the building official that they know that each of these dwelling units has passed these tests and has been commissioned correctly to the mechanical ventilation rates. Next slide. So as I said, this is available, the Red Calc Pro tools is available for all the versions of ASHRAE 62.2. And it has the ability to save files, print reports, create folders for particular projects. It's mobile responsive. And there's a whole bunch of other tools in there for other diagnostic testing. And then there's a free version available as well. Next slide, please. In addition to those resources to learn about building tight, ventilate right, we at WSU have been working with the home energy raters that are part of the ResNet network of energy raters. And if you are interested in working with any of those folks, we have a list of them. You go to our website and we can hook you up with those folks. They're great building science folks that can help builders and other stakeholders understand the challenges of meeting the energy code, meeting beyond the energy code. Many of these raters work beyond energy code. So it turns out that our code is very close to a builder getting a $2,000 energy tax credit. That's how efficient the code is. But you do need to work with a rater if you're going to go down that path. Another program that the Bonneville Power Administration and NEA and the utilities work on is PTCS, Performance Tested Comfort Systems for HVAC contractors. And they focus on duct testing and heat pump commissioning and that kind of stuff. Great resource for builders, subs, and building officials. Next slide, please. So what I'm going to talk about, as I said today, is the R2 low-rise multifamily, 3 stories or less. There's about 20,000. In 2018, there was about, we estimate about 20,000 apartments built under this R2 low-rise code. That's of the 40,000. The others were single family and townhouses. Most of these have individual mechanical HVAC and plumbing. This is a really important point. Everything I've seen so far that's been out there in the progressive multifamily has been central mechanical. This is much more challenging when you're doing individual mechanical, especially when you don't have architects, engineers involved, you have a developer, and also, quite often, there's never air conditioning required in the project. This is another really important thing. I ask you folks, if you look at the climate change models, what should the design temperature that we should be designing for summertime air conditioning loads 40 years from now? As you start these projects, you need to talk to your client about the need for AC, or you're going to end up having a bunch of window shakers hanging off these things in perpetuity. That's an important thing. Do you have mechanical systems, or are they individual, and are you going to use AC? Then the typical right now is there's not even a heating contractor involved. The electrician in these low-rise non-central systems installs the electric resistance, zonal heat, and the exhaust fan for ventilation. So the value proposition for HVAC installers here is, here's 20,000 units that you can build tight and help these folks ventilate right. Next slide. So if you want to go to our website, you will download the energy code. And the other part that I'm going to be talking about today is Washington's amendments to the International Mechanical Code. And we have amended the code in our state to require balanced ventilation in the IMC that governs these low-rise multifamily buildings. Again, I think we're one of the only states in the country to do that. Minnesota, I believe, as well. This means we got to get everybody up to speed on how to install 20,000 heat recovery ventilators or energy recovery ventilators or other balanced system soon. And we're going to look at ASHRAE 62 2019 and 2010. Ian's going to get into that and compare some of the rates. Next slide, please. We're also going to talk a little bit about the compliance certificate that needs to be in every apartment. It's got to show that the system has been air tested and documented, that the HVAC ducts have been tested, the whole house mechanical system flow rates have been commissioned. Wow, we actually have to measure them in every apartment and write it down on the compliance certificate. That's going to be a huge challenge. We can do it, and we've learned that when you do that, you get better QA, you get better O&M. Design installation shall be carried out in accordance with the manufacturer's installation instructions. We cannot do this by ourselves. You need to work with the manufacturers of this ventilation equipment. We've got a few on the call today. I think that they are the best resource for helping you to design and work the projects out on a case-by-case basis until you can come up to speed. Next slide, please. So the tools that we've used predominantly for compliance with the energy code are called prescriptive worksheets. There are basically, you go ahead and you try to put together a prescriptive envelope, and then you get energy credits depending on the size of the home. And as you see on the left is the old prescriptive worksheet. We will be rolling out a new prescriptive worksheet, and there'll be a separate one for single family and multifamily. The energy credits have gone up significantly, and this is going to be a challenge. Next slide. So some of the challenges that we're going to need to embrace have to do with changing their HVAC practices. As an option, we're going to look at electric resistance in all zones. That's pretty typical now. That's what the electrician puts in. There's a value proposition for many for the heat pump, a ductless heat pump in the main zone, and electric resistance in the bedrooms. I expect there's going to be a lot of move towards that if people want air conditioning and are willing to get the energy credits and maintain the systems, figure out where the outdoor units go. Ductless split system serving all of the zones instead of, so in other words, maybe something that serves the bedrooms and the main living areas, ductless and no electric resistance. That gets you more energy credits toward meeting the goal. Then, of course, we have these packaged terminal air conditioning heat pumps. And I'm going to show an example of how challenging it is when you try to use those with electric resistance in the bedrooms or put one in each zone. That's going to be an area where we're going to have a lot of discussion and interpretation and questions come in. Next slide, please. So the other envelope options, so we're going to talk about is the build tight, ventilate right. We're talking about 1 to 2 ACH 50 in a corridor loaded building. If it was a woody walk-up or a garden style where there's no corridor, there's a different metric. That's 0.4 to 0.16 CFM per square foot at 50 pascals, and that's a unit surface area. That's going to measure both compartmentalization leakage as well as leakage to the outside, whereas the whole buildings test with the corridor will not, and in fact will also measure leakage in the corridors like shafts and things. So we need to ventilate right with a balanced heat recovery or energy recovery ventilator in the range of 65 to 80% efficient to get energy credits. You can also get credits by going to triple pane with NFRCU factors in the 0.16 to 0.22 range. You can also get credits by improving your enclosure with R4 or better continuous insulation in a 2x6 or R21 equivalent wall. In addition, you can get credit with that one, you can get credit if you do your entire slab with R10 continuously, not just the perimeter, and or if it's a crawl space, R38 instead of R30. Another option is instead of taking these cookbook measures for envelope is to just compute a UA reduction in the thermal envelope assembly and get credits that way. So we have a whole nother 1 hour training session on these credits. And you go to our website and you can listen to me talk for an hour about this stuff. I'm not going to get into more details other than give you some examples. Next slide. We have options for heat pump water heaters, 1 per unit. I have some questions about that. If you're going to do that, make sure you talk with the heat pump water heater manufacturer to make sure you're following their instructions so you don't have noise or issues of cooling or pushback by the occupants. We see a lot of good demonstrated success with heat pump water heaters when you're serving multiple units. If that is an opportunity for central hot water, that is a consideration for credits. And then wastewater heat recovery, you can get credits for that if you hook up 2 showers per unit. Again, that's something that we didn't see a lot of, but there may be more people looking at that. I should note that there are control requirements if you have a hot water system with recirc pumps, and there is no credit in our code right now for water saving from improved plumbing design. But that's a good area to be considering if you're going with recirc and central systems. Next slide, please. Also, there are options for getting credits from appliances or PV. If you're going to go with the appliance credits, you need to have Energy Star, dishwasher and laundry and refrigerator, if those are provided with the home, and most importantly, a condensing ventless dryer. That means there's one less hole in the assembly, but something that's very new. So that's something to start doing research on. Do you want to think about that? Condensing dryer and getting this credit. Also, PV installed on a solar ready at the whole building level gets you up to 3 credits. A credit is worth about 1,200 kilowatt hours, and it's about 1 kW per credit. I hear in Seattle when they fail these blow door tests, sometimes they say you better have some mad money in the way of PV ready to go in case you can't get the building tight enough to get your CO. So think about making them solar ready in case Murphy shows up. At least I've heard that's an effective way. There's other ways of, if you fail, going to other sealing technologies, AirSeal and others that could be effective in helping you pass that test. But PV is an option, appliances are an option. If you're gonna think about PV, think about working with your solar company so that your subs can prepare the building as much as possible for solar ready, and they can put in the system as cost effectively as possible. Obviously, PV is more expensive than build tight, ventilate right, but there's a balance for everybody and there's a project need that's specific to every project. So think about these options. Next slide, please. So I'm going to show you, this is an example of a ductless heat pump in the main living area with electric resistance in the back bedrooms using triple pane, heat recovery ventilator, and a tight envelope, 2 ACH 50 to get you your 4.5 credits. I'm not going to get into the details, just show you this as an example. Next slide, please. Here's another example of DHP in the main living area with electric resistance in the zone in the back bedrooms. With a ventless dryer and the appliance package and a non-heat recovery ventilator, where you might try to figure out a way, I'm not advising this, but to wire an exhaust fan to a supply fan and make it all work. They're out there. If you're going to do that, make sure you're working with a manufacturer who's got this figured out and not just letting your heating contractor do a Rube Goldberg kind of, this is where things fail when people try to integrate things and they have no experience. But you can get there with a balance system that's non-heat recovery ventilation with a ventless dryer for this type of heating package. Next slide. Ductless split system. So now if you wanted to displace all the electric resistance and put a mini split or a cassette in each zone of the apartment and then put a balanced ventilation system in, you're good to go. And you actually got 5 credits. So you got a little mad money on that in case one of the things doesn't come through. Anyway, just consideration. Next slide, please. So electric resistance is what is out there now. And we see if you're going to do this, you got to get a really good shell. And if you're not willing to take it down the road to a good shell, you're going to need to be thinking about a ventless dryer, an energy recovery, heat recovery ventilation system with a tight home down to 1.5 air changes an hour, and PV, roughly 2 kW per apartment. That would be a 24 kW system on a 12-plex. Next slide, please. Here's another way of getting there. Balanced heat recovery or non-heat recovery system and a reduction in the envelope leakage of 30%. We'll have a design tool that will allow you to do those UA trade-offs. Next slide. And here's the P-TECH heat pump serving all zones. You're going to need triple pane. You're going to need an ERV and a tight envelope and PV. Next slide. So I was talking about the compliance certificates before, this is the one on the left is a 2015. The new 2018 is 2 pages. It's got the same information, but we get into more on the testing. Next slide, please. What we do on this is pretty much what's on there now, except we've added to the duct testing requirements a simple question. Do HVAC duct tests include GPS and timestamp verification? So there's outliers and outliers out there in the energy code world. Some people, write down numbers and they don't know better, and some people write them down because they're cheating. This, we believe, with the jurisdictions, after talking to them, will help to reduce that issue and make sure that when someone writes down what the duct leakage test is, or for that matter, the blower door test below, that the building official can say, let me see the test. Let me see that you did it on this day in this site. Next slide, please. So I've been working for 35 years on the challenge of build tight, ventilate right, and the ventilate right part is the one that we are working on, and I'm proud to say that we added this into the commissioning certificate under, and this is the first thing it asks you, are the system controls correctly labeled? And then the most important one, the whole house ventilation system operation and maintenance instructions were provided to the building owner. Provided to on what day? If you don't do this, Murphy shows up. So you need to know, what are the maintenance and operation instructions? How many of those instructions have to do with the building owner or the tenant? And you need to be able to understand that the person that may clean the intake screen on the 3rd story of the building is going to be somebody different than the tenant. But the tenant might have responsibility for maintaining the controls inside the apartment and maintaining the filter. These things have to be all figured out up front when you go to design and submit to the plans, or you're going to end up with the challenges that we've had over 35 years. Next slide, please. So the other things on the compliance certificate have to do with documenting what type of ventilation system it is. And if it's a system that's integrated to the air handler, make sure that it operates with a control sequence that's correct. And then you have to write down the flow rates. What was the design flow rate off the red or the calculation printout? And what was measured on the supply and return? And was it balanced? I get a kick out of the 10% balanced. We'll see how that works out. I just like to see the numbers be close enough, and I think we're going in the right direction. But try to keep these things balanced. Some of the new HRVs, ERVs actually have a printout, actually have a digital display that shows you these things and can tell you when the maintenance is needed. This is the direction we need to go. Again, can you validate this with GPS and timestamp? And if there's an HRV, ERV, what is the sensible heat recovery? And we have links to the HVI and the other directories where a code official, somebody can look up to see if you have put the right numbers down. Next slide, please. So Iain and I and a couple of folks wrote an article in the ASHRAE Journal about the importance of maintenance and operation. We're going to be doing more on this and talking about that today. Next slide, please. All right, so single family, I'm just going to touch on quickly. The IRC is what governs single family and townhouses. The IMC is low-rise multifamily, both corridor and non-corridor. In the IRC, Washington code is higher for exhaust only than balanced systems. And the IRC allows the use of 62.2, but not directly. We were hoping to get a footnote in there, and for some reason it didn't end up in the code. But what we really want to focus on today is the corridor and the non-corridor and the IMC R2, which requires balanced. It will not allow you to do exhaust only. And the IMC in Washington has lower rates than 62.2 2019. We're going to talk about that. And most, I suspect, are going to go to balanced HRV. Who knows what they're going to do with the PTEX. And the other thing I mentioned is compartmentalization is important. When we sat down with the Department of Health and others on the energy and mechanical tag, we talked about, the problems in low-rise multifamily when, somebody's not just listening to the rock and roll in the apartment next door, but smelling the marijuana smoke. And this interpartmental leakage of pollutants is something that building owners have issues with. By including compartmentalization in the testing for the low-rise non-corridor, we think we're going to improve upon that. Also with a balance system, but we'll see. Next slide. So this is your homework. Here's the IMC, here's the WAC that governs it. I would encourage you, and the scope is 1 and 2 family dwellings, multiple single family. That is not part of the scope. It's all about multi, low, and high rise. Next slide. I'm not going to go into these definitions today in 20 minutes, probably over on my time already, but you need to understand these and review the definitions in that code. Next slide. And more importantly, once you understand the definitions, you need to go in and look at each of these sections for your job on each project and say, how are you going to address these? If you don't address these up front, you're going to have issues at the end and put your client and your project at higher risk. Next slide. Here's some other things that need to be considered in the review of the IMC. These are all important and they're all fairly new to many people, especially if you haven't been doing central systems and high rise. Next slide, please. And then finally, these are some other ones that get back not into just the whole house system, but the controls, the certificates that are required for commissioning, and also local exhaust. Next slide, please. So I'm going to put a plug in for the ASHRAE 62.2 2019 user manual. I would encourage you, if you're interested in getting this manual, it's worth the investment, and it'll teach you and give you examples. Next slide. Here's some of the examples that are in there, real world examples. Next slide. They also talk about the fundamentals of the calculations, about how it computes stack height. The taller a building, the more infiltration. Next slide, please. And the challenges of integrated supply systems. There's some details on that. Next slide. So here's an example, and this is these great figures. This is an example of an exhaust-only system, which you will no longer be able to do in Washington IMC. Next slide. And this would be one where instead of using separate exhaust fans in the bathrooms, you have a central exhaust. Next slide. Here's one where you have a central HVAC system. Not very common in our apartments in low rise, but if you did, this is a situation where you could integrate the heat recovery or energy recovery ventilator right into to distribute it through the system. If you're going to do this, work closely with the manufacturers of both the HVAC equipment and the heat recovery ventilator. Next slide. Here would be distributed by taking outside supply air and distributing it through the furnace without a heat recovery ventilator. And then if you had it connected so that you have an exhaust fan running at comparable flow rates and running as whole house a continuous system, when you're running the supply intake, that would be defined as balanced if you can get them balanced. Next slide, please. That's it. So please, this is just the beginning. I couldn't give you everything in 20 minutes. And so this is a catalyst to getting you folks involved in understanding the build tight, ventilate right, and the value proposition for your clients in meeting the energy code. Thanks very much.
Thanks, Michael. We'll flip over to Iain. And as a reminder, there's a question and answer window. If you have questions, please type them in as we go, and we will answer them at the end.
So thanks, Mike. That was a great introduction. I'm going to focus a little bit more on some specifics related to ventilation rather than a lot of the other topics that Mike touched on. I want to start out with a bit of history. The current, these requirements that Mike was talking about for ventilation, they're based on ASHRAE 62-2010. And it had an equation for fan sizing, but it had a built-in assumption. It assumed there was 2 CFM for every 100 square feet of floor area of natural infiltration from the leaky envelope. And for a home in Seattle of a typical new home, that's about 4 ACH 50. The problem with that was below this infiltration rate, the home would be underventilated. And we realized that as homes were getting tighter, we'd have to change things. And that's what we did. I'll get to that in a minute. The other thing is that multifamily buildings generally have a lot less leakage to outside for the same size as a single family building. They just never had that 2 CFM for every 100 square feet. And why does this matter? Well, Mike talked a lot about blower door testing and air leakage, and I assume that most of you here tonight know all about air leakage and are familiar with blower door testing. And that the point is that in the world of 62.2, you can get what's called an infiltration credit that accounts for that leakage, and it reduces effectively the fan size that you have to install. In 2010, multifamily buildings got none of this credit. There was the fan size, that was it. You were not allowed to reduce the fan size if you had a leaky building. And Mike just pointed out that the new Washington Code is going to require balanced ventilation. That is not a requirement from the 2010 version, which the fan sizing is based on, and it still is not a requirement in 62.2. So what's happened since 2010? Well, from 2013 onwards, we changed to a target ventilation rate. We got rid of that assumption that you had a leaky house. And so we now have a target ventilation rate you have to reach. And there was still no infiltration credits at all for multifamily. So you still, even if you measured how leaky the building was, there was no way to turn that into an infiltration and reduce the fan size. We did recently change that for a subset of multifamily buildings. So multifamily units that are attached horizontally, so this is row and townhouses rather than units stacked on top of each other, they are allowed infiltration credit that's proportional to the exterior envelope area. And Mike went into a small example of that using the red calculations and a few examples. Again, you've got to do a blower door test. You have to know how leaky the building is. And we also upgraded the infiltration credit, and basically it accounts for the difference between a balanced system and an unbalanced system. So from the point of view of a balanced system, if you calculate the flow in your balanced ventilation system, you can just add that to your calculated infiltration. For unbalanced systems, you can't do it. It is sub-additive. In other words, the same flow through a balanced system will have a bigger impact on the total ventilation than an unbalanced system. So if you're going to have the same target, you will need a bigger fan flow if you're unbalanced. And Mike already talked about online calculators. I also like the residential dynamics one, but there are others. The next thing I want to talk about is this table, 403.4.3, which is this thing called system coefficient that applies to the airflows required. And you see that it distinguishes between balanced and unbalanced, which we just talked about, and distributed and not distributed. Now, this is a table that was suggested for ASHRAE 62.2 several years ago, but it was rejected for a few reasons. One was this differentiation between balanced and unbalanced. Turns out there is a much better way to combine those things that accounts for the changing envelope leakage. In other words, the difference between balanced and unbalanced depends on how leaky the envelope is. And I'll give a couple of examples in a moment here. And then what does distribution mean? If you take what Washington has adopted from the IMC, it says you've got to exhaust from kitchens and bathrooms and supply to other rooms, which seems like a pretty sensible thing to do, right? You should exhaust from the rooms that we think have the most contaminants in, whether that's odors or cleaning materials or moisture from cooking and cleaning and so on. And also, you know, some of the odors related to people. The thing is, to do that, you're going to have to do some sort of ducting. Mike gave a few examples of how you might install a distributed system that was balanced. There will be some ducting required, which not all simple systems have that are suitable for use in low-rise multifamily. Another tricky thing is that if you have a central forced air system, which I know is rare in the buildings we're talking about in Washington State, if you start mixing with a central forced air system, you undo all the good that you're doing by trying to separate things out with your distribution. And the last note is the values in this table weren't developed for the definition of distribution we're talking about here. And they weren't developed to include all the contaminants we think about. For example, stuff like formaldehyde is generated evenly in a home, and it doesn't matter if you distribute the ventilation. And kitchen and bathroom contaminants, you don't want to mix the air because you bring those contaminants to you. And Mike and I have thought about this as the I stink, you stink problem, where we're talking about mixing contaminants in a home with a central forced air system, which is that if you stink, you want to mix with as much air as possible. That's awesome to do the mixing. But if someone else is in there with you, or other things are happening like cooking and cleaning and so on, then you don't want to mix. And these things sort of got convoluted into this table. And because of this table was not used in ASHRAE 62.2. So let's talk a little bit about this balanced versus unbalanced, why this simplified approach might not work well. I'll start out with something that you don't want me to talk about because we're supposed to be talking about multifamily, which is single family. So this is an example for a typical home in Seattle. There's a bunch of colored lines here. And what we're seeing is the fan flows on the vertical axis, how leaky the house is horizontally. So you see that if we look at the blue line first, a balanced system according to 62.2, you require a smaller and smaller fan as the home gets leakier. The red line is the same thing. The leakier the house, the less flow you need in your ventilation system. But an unbalanced system, it doesn't add linearly, so you can see it is different. You do require more fan flow compared to a balanced system. What's a bit tricky, though, is that what's happening in the Washington Code is there are fixed numbers that don't vary with home leakage. And these fixed numbers also have a fixed difference between balanced and unbalanced. And this isn't really how houses work. It also has this problem that the tighter homes that are now required by code tend to be underventilated with this fixed airflow approach that's happening in Washington compared to 62.2. So that's for a single family house. Is this also true for multifamily? So if we look at a multifamily building with a corridor, all these lines are the same. And again, we're looking at here, now we're looking at the whole building leakage, as Mike pointed out, and the fan flow. And again, we see as you increase the building leakage, the 62.2 calculations decrease the fan flow that's required. The Washington State Code is going to say this has to be constant. And again, we get to this problem where tight or cold homes get underventilated with this approach. And that difference at a 0 building leakage is exactly that built-in assumption in the 2010 fan sizing that's used in the Washington Code of 2 CFM for every 100 square feet. And my final example here is the other kind where you don't have a corridor. There's lots of terminology. Walkup is one way of putting it where there's no corridor. And here, what we're doing is we are scaling with the leakage of an individual unit. This is the CFM per square foot number that Mike also talked about, where you're testing an individual unit rather than the whole building. It's a very different metric. But again, you see the same trends with the 62.2 calculations showing how as you get leakier, you need less airflow with your mechanical system. And again, what's proposed and is going to happen in Washington has code homes end up being underventilated with this approach. There are things other than this balance versus unbalanced topic that are happening at 62.2. And this is just to give you a flavor of some changes that might be happening in the future and the things that we need to think about when we're ventilating multifamily buildings. So this is not just 62.2. It's going to apply to the daily practice that you folks are all involved with and future code changes and so on. This idea about compartmentalization, where we're trying to not just reduce the flows in and out through the exterior envelope, but reduce the flows inside the building from unit to unit or between the unit and the corridor and so on. And 62.2 currently has a limit that's 0.3 CFM 50 per square foot. That square foot area is all 6 sides, not the floor area, I want to point out. That's probably too leaky to control these airflows well. You probably need to be down at 0.1 or less. And we're seeing a trend to this in new construction. Multifamily buildings are doing a much better job of this. There are some questions that we need to answer though. If we go super tight, do we need makeup air systems for kitchen and bathroom exhausts? Even if you've got a balanced system for your whole house ventilator, those are interesting questions because those tend to be expensive propositions in residential. We're currently studying this issue of, what might be a reasonable compartmentalization limit. Maybe I'll come back next year and we'll see if we've changed our minds about those numbers. There are great challenges with limited wall area. 62.2 and other codes require a minimum of 10-foot separation between inlets and outlets. That's tricky. They tend to be too close on multifamily simply because there is limited wall area. Some ventilation-only products can be certified to have closer than this, but we're talking here about the inlets and outlets for kitchen exhausts, bathrooms, and dryers. As Mike said, the trend in particularly low-rise multifamily is that they get all their own individual systems. There isn't like a central rooftop unit for any of this. So we're really, really having a struggle to meet this 10-foot separation rule. And there are questions about maybe we could relax this. And in fact, there's some wind tunnel experiments, new studies underway to reevaluate this to see if we could maybe have some exceptions to this 10-foot separation rule. Essentially what's happening is there's this rule in place and it's being ignored all the time, and that's probably not good. Something that has been looked at before is this idea of passive, or what I'm going to call trickle vents here, where you may have an unbalanced system, typically an exhaust from a dwelling unit, and the air would come in through a trickle vent. And historically, these have been installed very poorly and did not work because they weren't installed right. The holes were not cut the right size, and there's a whole host of issues with them creating drafts and other things. There's a working group at 62.2 trying to develop new guidance for these products, looking at minimum air leakage to make sure you get the right flow and sizing requirements and so on, and thinking about filtration and tempering. And there are products and ideas we can adapt from other countries where these systems are very popular. Examples from Sweden, for example, is these air inlets are placed either right behind or right next to the heating elements, whether that's electric resistance heating or most likely in Europe, hot water, so that you get some tempering, for example. And the big question is, should we require balanced system? It's currently being debated at 62.2. Unfortunately, the field says we have a kindly inconclusive And Mike also touched on this. What we find from field studies is that it's hard to know if balanced is better than other systems because all the systems we find are very poorly installed and maintained. They so rarely comply with flow requirements that we really can't tell. There have been some studies that show, exhaust systems are actually not too bad with very little drawn from other units. And it's clear that things have got better. There were older studies that showed much higher flow between units. So this is something that's currently under debate. And boy, we would really like to have more data on this. And that's what we're working at finding out. And lastly, what about buildings that have corridors? And quite often, more so in high rise than low rise, the corridor has been used to supply filtered and tempered air. It's very common in some places. Some jurisdictions have specific requirements, and it's likely that 62.2 will have to add some of these specific requirements if we're going to allow corridor supply air. So I want to now shift gears and talk about what's underlined and bold and red on this slide and talk about reliability. We're currently conducting a study sponsored by DOE to look at homes all over the country, about 150 homes altogether, to see what's going on and what's actually gets installed in homes. Now this, I have to say, the caveat here is this is single family, not multifamily, but we don't think multifamily is any better based on previous studies of multifamily systems. And what we find is there are operational issues. Most systems are turned off. In the California study that I was part of, we primarily had exhaust systems in single family homes. They had unlabeled or poorly labeled switches that were simply in the off position. We did have a handful of HRV and ERV systems. Because the controls were harder to access, they tend to stay on. The other states, though, didn't quite find the same thing. They found that the operation of systems was independent of system type. And we found a lot of systems, particularly supply and supply dehumidifiers, that had broken dampers and controls. They were miswired. They had incorrect ducting, and they simply weren't functioning. Exhaust systems, because they're simpler, did function well, but they weren't turned on very often because they had these switches readily available. And this leads us to believe that we need a lot better commissioning to make sure that things are actually functional and better labeling so that people know what that switch on the wall is doing. There's a whole bunch of issues about commissioning, and Mike mentioned this. In our California study, we found that on average, we had about 150% of the minimum requirements for exhaust systems, so far exceeding the minimum. So that seemed pretty good. But that's a code requirement in California. In other states where ventilation is voluntary, flows are much less likely to meet these minimum requirements. There's huge issues with inlets for supply and balance systems because they were inaccessible. We simply couldn't measure them. And that's going to be a big problem for enforcement. If you require balanced systems, you have to be able to access them to make sure that you can measure the flows in and out. I'll talk a little bit more on that in a minute. And supply and balance systems were found to very rarely meet the minimum airflow requirements for a host of installation rules. And so this gives me some caution about the requirement in Washington State to require balanced systems. We know they're not installed well and they have lots of maintenance issues. For example, the manufacturer says you usually have to replace the filters every 6 months and then it's cleaned every 6 months. And I want to know who's going to do that on a 3-story building? Who's cleaning the inlets and outlets every 6 months? Do we require that? Probably we should, but it's very difficult to implement that in a code. And we all like to see horror stories, and I have some here, about what goes wrong with our inlets and balance systems. I've talked generally here. I just want to give you some pictures so you have an idea of what we're looking at, so that when you're out there in the field trying to figure out, am I doing the right thing? This is what you need to look out for. This is a study of HRVs in Canada, and these are pictures just showing typical things they found. Clogged inlets, not replaced filters. People didn't know what was supposed to be done with these systems in terms of maintenance. This was a study of high performance buildings in California that had heat recovery. The ducts were installed incorrectly. They didn't have the right airflows. They had clogged inlets yet again. This is a photograph of a disconnected duct. In Florida, I know it's not Washington State, but guess what? They found exactly the same thing. These were mostly supply systems. They had terrible problems with plugged air inlets. Almost none of them had airflows close to design. Many of them being disabled, lots of faults. The main point is ventilation is kind of new. And particularly if we're going to have air inlets via the supply systems or balance systems, they're a huge maintenance challenge, and we need to really be on it. And in terms of verifying airflow, it's not so simple. If you're trying to do this from the outside, some things are high up in the air. And if we go 3 stories up, you have to have something like scaffolding or whatever, or a very good cherry picker to go up and measure those airflows. And, you know, even for single family, single story buildings, it's tricky to access those air inlets. And people say, well, that's okay. I'll just go inside and measure stuff on the ducts. And I know you don't have many central forced air systems in the building types we're talking about this evening, but this is just illustrative of if you can get at the ducts, they often have like lots of elbows or lots of flex in them. There's no place to do a velocity traverse, which is what a lot of HVAC contractors tell me they want to do. You just simply can't do it on these systems. And lastly, this is what Washington State is going towards. It turns out that 4 connections are much harder to get right than 1. Maybe 4 times is about the multiplier there, could be more. And the picture on the right there is what I would like to see on the outside of every single HRV. We don't have that yet, but we should probably require it. So one more little thing about measurement. Why is it so important? Because we're building tight. If we don't have mechanical ventilation, there's no natural infiltration backup. And it's a big question about, there are various measurement techniques here. How good are they? Again, Mike touched on this earlier about this idea of, can we accurately measure the small airflows we're talking about, particularly if we're going to go to distributed ventilation, where each inlet and outlet is maybe only 10 CFM. This is just some examples from what the manufacturers claim for minimum airflows and accuracy. And you can see the minimum airflow and accuracy is pretty close to that target we're trying to measure. And again, as Mike said, trying to get to plus or minus 5% out of maybe 40 to 50 CFM total for a multifamily dwelling is just not going to happen with these instruments. And that's a huge compliance problem. How are we going to verify these super low airflows if we can't access the inlets on the outside and the inside? I think this is a big challenge that you're going to have to face in Washington, and I don't have a good answer for you. I do have hope for the future, though. There's a whole bunch of instrumentation coming along that's going to be great for diagnostics to diagnose airflows. The illustration here is from some of your neighbors to the north up in Vancouver. This is a Canadian company. There are many others. This is just an illustrative example. You put this probe in and you get a nice output on your iPad or your phone. This is really going to make commissioning easier, and I think we'll get there in the end. I'll just have a couple of slides here, just so we have some time for questions. Other stuff to think about when you're designing multifamily buildings. If you're going to have controls where systems maybe cycle on and off, you want to have the same controls in each unit, particularly if you have unbalanced systems. It might be a good idea to install a bit more extra capacity above code minimum. A huge issue in high performance multifamily is overheating in the summer, particularly if you are not installing air conditioning. We have this problem in California in spades, where high performance multifamily buildings are chronically overheated. But this means that a bunch more ventilation capacity with ventilation cooling might actually be a really, really good idea in high performance buildings. Both in the state of Washington and California, we have plenty of cooler night hours and morning and evening hours where we could do this. But to do that, you do need a bit more capacity. Also, the minimum flows are designed for a basic level of occupancy and a basic level of activity. So if you do stinky things, or if you have a bunch of people over, maybe you want to have a button that allows you to increase ventilation. And lastly, I really want to emphasize the installation of better filters. This is not required yet in 62.2, but I believe it will be soon, and it is required now in the state of California. And if you're concerned about wildfires and COVID transmission, you need MERV 13 or better in your filters for a recirculating system, and also on any outdoor air to remove, particularly for wildfires, to remove wildfire particulates. So I'll end with this final slide to sort of summarize the main points here. I would highly encourage folks in the state of Washington to consider allowing 62.2 as an alternative pathway. It has a lot more flexibility with regards to the difference between balanced and unbalanced systems. There are new multifamily requirements coming. If you're going to have a switch that is accessible to the occupant, and I want to note that 62.2 requires remote switches in multifamily, but that's really not going to happen if you're going to have individual unit devices. You've got to have really clear labels, and they must be on the switch. And here's an example that we've been working with the folks from the Home Ventilating Institute as something that would be compulsory. I think this sort of thing needs to be compulsory. You've got to commission your systems. And I've just explained how difficult / impossible that is, but you've got to do it somehow. And we're going to need some better diagnostics. If you're going to have balance and supply systems, the outdoor air inlets need to be easily accessible for cleaning regularly, which means if you're on the 3rd floor, that's going to be tricky. Again, it's going to be so hard to measure the terminals on the inside. So we're sort of stuck between a rock and a hard place. The outside is hard to reach. The inside is hard to do. Again, if you would allow exhaust systems, they tend to be much easier to commission, but that's a whole other issue. And now we're requiring by code these complex systems that people are not ready to install. As Mike said, ventilation is currently installed usually not by an HVAC contractor, but by the electrician. They don't know about these systems, right? And maybe they could be trained, but it is going to be a huge issue. And the manufacturers of these ventilation systems are installing. I put in a quote here from Panasonic about how often they have to be maintained because they're more complex and they need this maintenance. That's something we really have to be considerate of when we're talking about installing these more complex systems. And I'll stop there so that folks can ask questions of me and Mike.
Thanks, Iain. Thanks, Mike. There have been a few questions in the chat that Mike's already gotten to. But for attendees who haven't seen that, there's a question about what he meant by warm surfaces early on in the presentation. And Mike's answer is the continuous R4 insulation warms the OSB so that it prevents moisture from condensing there, or reduces the chance, I guess. And then if a crawl space is used, where should the air vapor barrier be located for a building in the Pacific Northwest? And Mike said the flooring is typically the air barrier in a vented crawl space situation. A couple more questions here. I can address, Brent. We are recording the presentation and we will figure out how to post it to both the SeaBEC website, and I assume that Michael and Iain may have places that they want to post it as well.
Yeah, I'm happy to make a PDF and for you folks to host it on your website. That's not a problem. I think Mike will do the same thing too, right, Mike?
Yep.
Yeah, so both PDFs of the slides and a recording of the event will be available.
Yeah, no problem.
So energy code used to favor gas heat, hot water, etc. Why did it change to favor electric?
I can answer that one. The way that the Washington State Energy Code works is that they have a base case and a bunch of prototype homes, and they do a life cycle cost analysis to determine that the improvements to the energy code are cost effective. And as, of course, as you get up to more efficient base case, the fruit is higher on the tree. The low-hanging fruit is hard to get. But we do use that calculation for the energy credits in our code. And recently, the state legislators worked towards policies of decarbonization based on the assumption that our utilities, a new generation, is predominantly renewables. And so, as I didn't get into here, but as you will see in those examples, there's what they call a fuel equivalency factor, which means if you use a gas furnace or a fossil fuel heating device, you don't get any credits. If you use a minimum efficiency heat pump, you get a credit. In addition to higher efficiency credits you get in the energy code. If you put in a PTEC, you get 0 credit. If you put in electric resistance heat, you get -1 credits. So what it's going to do is really challenge folks to think about, is my development going to be served by natural gas? And what are the ramifications for that when they're serving as space heat in the apartment? And as I said, these are pretty, typically they're individual units. And the units right now are predominantly electric resistance. I don't think they're going to go to gas in these low-rise multifamilies. I think what they're going to do is be challenged to figure out, do we really want to bite the bullet and put air conditioning in or not? And if so, how does that help us justify the investment in an energy efficient ductless mini split or split system that serves more than just the main living area? That is really critical. It gets back to the issue of, do you have a central system and are you going to do AC? Until you answer that, it's hard to know. But certainly, I think the fuel normalization credit is going to be something that we will be working on, not just here, but in California and other areas as we look to decarbonize, or whatever they call it, the power grid. Thank you. Hope that helps.
So Mike, to kind of summarize it, from your view, particularly for this type of building, it's not so much a switch from gas to electric as it is from electric resistant to electric heat pumps, both for heating, cooling, and hot water?
Well, the hot water is not a requirement. The fuel normalization credits are only based off space heating. So, but I think you'll find that heat pump water heaters are going to be an option in the energy credits that people are going to want to look at. And I don't want to get into that right now, but the credit, the fuel credit is just on space heating.
Yeah.
I had a question. I do a fair bit of work in condominiums. And so when you're talking about centralized systems and remote control for HRVs and things like that, is the code contemplating individually owned multifamily units as well?
I think that, you know, basically for this low rise R2, that's what we have. We have, whether they're condo people that own each apartment, or whether there's somebody that owns the building and rents them out, there's very rarely a central system. And what I wonder about is, can a person who's designing a sustainable multifamily low rise, can they make the value proposition to the builder or the developer that they may want to consider central plumbing or central HVAC, central ventilation? That's a hard sell in this industry. I think we had a comment from Ken Nelson from Panasonic that might be useful to share.
You want to read that off, or do you want me to read it and then you guys can answer it?
Yeah, that would be great.
All right.
Mike can read it and I'll answer it.
Yeah, you get to answer it, Ian.
So at Panasonic, we're moving towards ERVs with corded power supply. As a result, we're seeing more installations being completed by HVAC installers who are more experienced with ducting, sealing, and control functions for the homeowners, as well as we give low-speed, high-speed control on all our exhausts-only whisper green strategies and our ERVs.
Yeah, I think that trend might continue if we're going to go down this road of more complex systems, right? It might not be. It might be the electrician does not install it, right? And hopefully, an HVAC technician knows something about airflows and ceiling ducts and all of that sort of stuff, because they've been through that already, you know, and work that we've done in previous years related to forced air heating and cooling systems, right? They understand about ductwork and sealing it properly and how to run the ducts correctly. So hopefully we will see better installations when that happens. And I think that I'll ask Mike, are there plans to have more training for helping either HVAC installers or electricians to, you know, better understand this new thing they're being asked to do?
That would be nice. That remains to be seen, right? As I mentioned, we working with ABBA on the getting the building tight part right. Now it behooves us not to get the ventilation right. And as you and I know, Ian, have been doing this for 30 years. If this stuff was easy, we would have already done it. Now, what we've got going on is we've got industry manufacturers. You and I went to the ASHRAE trade show before COVID hit. We talked to a lot of air-to-air heat exchanger and HRV, ERV manufacturers, and we told them what was coming down the pipe with Washington State. Balance requirement and requirements for measurement and writing the measurement down. And I said, how many of you guys are going to have pressure taps on your unit so that you can repeatedly balance these systems? How many of you folks are going to have digital displays that show the consumer or the balancing contract or anything what those flow rates are? Those are the things that need to happen into the future to help us get up this learning curve. In addition, Iain and I have been working on smart ventilation controls that are connected to the grid that engage the consumer like, say, a green leaf does. We kid about, should there be a little display in the unit that has a Mr. Yuck face icon if the system isn't operating correctly, and a smiley face if it is. These are the kind of real world challenges that we really have been addressing for years and improving on. I think the smart ventilation control and the industry's responsiveness to the need to commission residential systems will help move us in that direction.
Yeah, I mean, just to add to that, Mike, I was at the HVI National Conference last year talking about these exact things. And when you talk to the engineers at the various product manufacturers, they're aware of these issues, and they basically know how to relatively inexpensively put some sort of standard flow meter in the device itself, which would make life so much easier for installers and people doing commissioning. It's just the world isn't quite there yet. I think we can get there over the next few years, but there is a bit of a chicken and an egg thing, right? If there were more requirements to measure these airflows that were enforced, then there'd be more pressure on the manufacturers to have products with things like built-in airflow meters and displays and so on. But the folks, not just in the state of Washington, but I have these same discussions here in California and also at the national level. Nobody wants to, quote unquote, require that these devices have some built-in airflow capacity unless there's plenty on the market. And we've got to move off square one, and maybe, Mike's implying that, this big change in the state of Washington is what will give the push to manufacturers to do this once there's enough wreckage on the floor.
Good. We hope to minimize the unanticipated consequences, and we have worked productively with the industry over the years, and we just want to be transparent and let you know the challenges here that we're up against. As far as the question on the funding, we do believe that the state needs to put some resources towards the building of the skill set of the workforce in the green jobs. We have adopted the most, I think, is the most energy efficient residential code in the country. And we need to put our money where our mouth is if we want to get the realized savings without unanticipated consequences of air quality and health and safety. The costs that I see from health and safety implications of poor air quality to society are much larger in general than the energy savings associated with energy codes. Yeah. And really important. And I think we're moving towards that so that it's not just Melinda and I running the whole energy code program for the state, that we're partnering with HVI and ABA and others, and we're getting utilities to support and fund these training efforts. Thanks.
Great. We got a question from Lee Kranz that says the code now requires electric infrastructure if you install a gas HWT. Why did that get into the code?
The requirements for fuel equivalency were put in there based on the legislative direction that we are going to save carbon and minimize our carbon footprint as a state. And it is going to challenge all of us. I remember when I started 30 years ago, it was like, gas was everything. Oh, of course you'd go gas, go gas.
Cooking with gas.
It's 180 from there. And I think in terms of the context of R2, we've never really, in terms of these individual units, very rarely do we see gas heat. So it shouldn't be as big of an implication. Where it's going to be the big implication is the gas just gives you 0 credits. The electric resistance is 1 negative credit. And God knows where the PTEC is going to figure out to be once the interpretations of the code assign it a fuel normalization value. I understand now they're talking about assigning it as an other. If it's a PTEC heat pump. I'll tell you right now that what I worry about the PTECs, and I'll get into this and then I'll shut up, is that there are a hole in the wall that leaks. And Walsh Construction taught me about this many years ago when I started. They showed me infrared scans of buildings they did with PTEX and failed blower door tests. So when the local governments call me up and say, I got a guy with a PTEC, I got nothing to say. There's nothing in the code that says they can't use it, except they may fail the blower door test and they may have a big hole in the wall. And I see $1 million condos in downtown Olympia with PTECs. We're not going to get sustainably to our goals of carbon credits going in that direction. So we'll see where that technology goes. Maybe we can get a VRF PTEC that isn't a hole in the wall and leak. We'll see.
Well, it's certainly possible, Mike. I mean, it just, you know, again, it's not beyond the wit of man to put a damper in your PTEC, right? It must, you know, I'm a mechanical engineer. So that sort of thing is like, yeah, of course we can fix that. It's just that if you want to go out and buy one right now, not so simple, right?
You know, you can wire the bath fan to the supply fan on the PTEC and call it balanced and, you know, do one of these. What we need to do is engage the industry through market transformation so we get a PTEC product out there that reliably does HVAC and provides efficiencies of the heat pump that we're seeing in modern heat pumps.
Yeah, Mike's right. I mean, all joking aside, what Mike and I spend a lot of our time doing is talking to manufacturers about, you know, here are some changes to building codes, which mean, you know, this for your product, you know, what product changes, you know, are needed to best comply with the code in a reasonable way. So that is a lot of the effort that we do here. For example, the ASHRAE 622 standard is full of manufacturers of equipment, right? So they're fully engaged, you know, in addressing these. I mean, Mike and I might have painted a slightly bleak picture, and I don't want you to go away and think, you know, the sky is falling. There's a lot of work going on between researchers and folks in codes and the manufacturers of equipment to try and figure this stuff out. And I think we will get there. We're just not quite there yet.
Great. We've got one more question from Sean Slocum, who asks, Iain, in your opinion, what other trade emerged to maintain these HRV, ERV units, or will HVAC or electricians take this maintenance on?
Yeah, unclear. So I know that there are some changes happening in the HVAC industry to get away from we're just going to come and install a furnace or a heat pump or what have you, and get more into service where we're going to sell comfort. And instead of, you know, spending $5,000 every time you have to replace your heat pump, what they will do is they'll say, well, for $100 a month, we will guarantee some service. And so it's not really there yet, but there are some large companies working on this. Let's just put it that way. In which case, the maintenance gets done. The problem we have now is that, generally speaking, whether it's the electrician or the HVAC installer, new building, thing gets installed, they walk away and they never see that building again.
Yeah. Never
see it again. So the maintenance is then down to building owners, and how do they figure it out is unclear. I mean, often for larger buildings, they will have an HVAC company that they have some sort of standard maintenance contract with. And there is kind of a clear division here between buildings that have central plant for both hot water, heating, cooling, and ventilation, and buildings that have it in individual units. And the central plant stuff, generally we find that these buildings do have an ongoing maintenance contract with an HVAC company and or a plumber for the hot water, and they take care of those things. But it's much rarer to see these sort of things in place in buildings where each individual unit has its own hot water, heating, cooling, ventilation system. Because it's a lot more work, and frankly, it's just harder to do, right? Frankly, it's a tougher nut to crack. But when we're talking about building design, maybe we need to start considering these sort of ongoing operation and maintenance issues. And, you know, and I understand people's reluctance to say, well, no, I've got to give up floor area because I'm going to have some vertical chases to run all my ducts and my plumbing in. Well, you know, maybe that's the price we pay for high performance buildings that perform reliably, not just now, but in 5 years. Currently, building codes don't really address what happens 5 years down the road. But maybe we should think about more. And certainly, I'm assuming the sort of folks who've tuned in this evening to hear Mike and I ramble on about ventilation and high performance buildings, you are the sort of folks who are already engaged in this sort of thing and thinking about these issues. Like, you want your buildings to be high quality buildings that last. You're not just throwing something together to meet minimum code, then running away as fast as you can, right? So I realize that Mike and I are kind of preaching to the choir slightly, but what we hope is that you take some of these ideas on board when you are planning and designing buildings and thinking about that sort of stuff.
Absolutely going to be a difficult conversation for the designer to have with the developer. I got good news and bad news. We need to talk about do you want air conditioning and the pluses and minuses of doing that? And what does that increase the value of your rental? If it's a condo at high end, better value proposition than if it's low income housing. That's going to be really important conversation. Who is going to maintain each component of this ventilation system, whether it's a central system or more challenging, as Iain points out, a decentralized system? And what are the components that will be maintained by the building owner and which ones will be maintained by the tenant? Until you figure that out, you can't design a system. And so you got to figure this stuff up front with your building developer and have these hard calls. I can tell you that of those 20,000 those 20,000 units in 2018, less than 5% of those were central systems.
Yeah.
So there's a huge challenge here, and this organization, I know that we've talked with a lot of folks within that are here and others that are leading on this, but most of them, their experience is in central systems where there's a lot of money available for A&E. That's not the case here. That's why there's a challenge. That's why we got to work with organizations like HVI and others to get the training and the skill set out there to ventilate right, as we're successful working with ABBA and others to build tight.
Yeah, I mean, you know, for multifamily, there's hopefully somebody coming to clean out the dryer vents every now and then, but they're certainly not coming every 3 months to, you know, brush vacuum your HRV vent.
Well, instead of cleaning the dryer vent, maybe they'd go to a ventless dryer or something, and who knows? It's going to be interesting to see how it plays out. Sorry.
Go ahead, Nathan.
So we're at 7:02. There's a cat that just jumped on me because he wants dinner. Sorry, my camera's not on, or I would share. We got one more question from Philip, who asks, thoughts on the role of fault detection systems in residential systems for CX and ongoing CX? Commissioning questions. Sure.
We've touched this already. I'm a big fan of that. And like I said, I've been talking with all the major manufacturers of not just ventilation systems, but heating and cooling systems also. And again, it's that chicken and the egg problem. They can do it, but you know, if they can make an extra $1 or $2 on every sale by not doing it, and the market doesn't require it because it's not in code, or you know, advanced building designers like the folks on the call tonight don't require it, then it won't happen. But I will say, I am seeing more and more devices show up. Mm-hmm. Several manufacturers already have product out there that has some sort of flow sensing built into them that's easily accessible by the installing technician, and would be easily accessible for a technician, you know, a year or 5 years from now to come and recheck on airflow. So it is definitely happening. It's not common, but it's already started, I would say. And the next step is something that Mike sort of touched on briefly again, and which is if we make these things not just something that a technician can connect a device to, but if they've got a little wireless transmitter on them so that it sends a signal to this, then you can check it any old time, right? And like I said, businesses can come along and say, we're going to put these devices in, and we'll send you new air filters. We'll detect when your air filter in your system is clogged, and we'll send you a new one automatically. It'll just happen. Those companies are starting right now. And so this is all coming. And you folks need to be aware of the potential of these companies and start looking for them and working with them. But that's happening right now.
Thanks, Ian. That gets back to our whole smart ventilation control research. We're looking at fault diagnostics once we're connected to the Internet of Things, whether it's for the building owner, the occupant, the tenant, or somebody that's a contractor responsible for maintaining it. It's a value proposition for the building owner. I would ask the building owner up front, do you really want to know whether people are running their ventilation system or not in the buildings you own? And if so, then how are you going to include that in the rental agreement or in your condo association requirements?
Right. And one other comment on this, I'm just not familiar enough with your electric power supply system in the state of Washington, but I am very familiar with the one in California, which is heavily challenged. And utilities really, really want to send a signal to your home to maybe turn down ventilation a bit or adjust your set point a little bit and so on and so forth. And they are going to pay for onboard devices that are wireless capable, that can send and receive signals. And it's the chances are that if California does it, eventually the rest of the country will follow, you know, but
unless Washington does it first.
There are utilities are going to, it might not be that the utilities are like going to directly control your air conditioner, because most people hate that. But what they are going to do is have a rate schedule that means that you as the occupant would love to sign up to a program that did that, because there'll be some financial incentives to do so. And that's why I think we're going to see more and more of these onboard diagnostics, particularly onboard diagnostics that you can wirelessly connect to or Bluetooth connect to. They're going to see a lot more of those because utilities are going to start pushing them big time, particularly as we switch to more electrification. There is going to be a lot more stress placed on our electric grid and the need to manage not just energy use, but to manage things like the peak demand. You know, when everybody wakes up at 7 a.m. on a winter morning and everyone's heat pumps turn on, which used to be gas furnaces, that's a big issue. Less so in Washington, I understand. But this is why you have incentives to swap out electric baseboard heat for heat pumps, right? It's a peak demand management problem for the utility, right? There's, it just requires a lot less electricity to heat your home with a heat pump than electric resistance. Yep. Anyway, I'll stop there.
I've got one more question for you guys, and that's just what can we do to further your mission, like as SeaBEC, as architects and engineers and product reps and contractors? What steps should we take to help you guys push these technologies and these codes forward?
You got that one, Ian?
Yeah. So I got a couple of ideas. I mean, first of all, you know, all these things we've talked about this evening are all things that, you know, you folks are all aware of. So, you know, you are the folks who are going to be pushing for change, right? You're building the advanced buildings. You're going to be going to the HVAC companies you work with and say, look, I want to have a better heating, cooling, ventilation system than we've been buying for the last 10 years. Can you look at some new products? And you'll be installing these new products. And that's how things will change, is you can push that market if you're involved on the sort of building design aspect of things, for sure. And if you're not the building designer, but if you're just looking at the envelopes part of it, you'll be on a team and you can raise these issues. You can say, look, we're going to use these great products to build airtight buildings. But if we do that, we better get our heating, ventilating, and cooling right. And so if you're going to use my product on this building, I highly encourage you to look for these advanced products that manufacturers are now producing. And that's sort of, you know, pushing the market from the other side, if you will, I think is vital to, you know, transforming the way that we have, how we're dealing with our energy efficient buildings. And on a more, I'll say, personal note, I'm a researcher and I'm always on the lookout for people to partner with to test out advanced products and things like that. And so I'm always interested to meet folks like who've called in today and you folks from Building Envelopes Council, because you are our partners when we want to try new stuff, right? We always get to that point where it's like, well, you know, if we want to test out some sort of smart ventilation control that avoids, you know, peak heating ventilation loads on a winter morning, we need to test out some buildings and we'll have to partner with you.
I'll just touch that one for a bit and let you know that if you believe that there's a skill set gap in the trades for Ventilate right, then I would encourage you to talk with your utilities and your representatives and others and point out that this stuff is hard. We've been working on it for 35 years. And you expect what you get. And I think that if there's resources provided by the state to do workforce training in green jobs, healthy green jobs, we'll be successful. So I ask you, I'm not telling you to go lobby because I get in trouble when I do that, but I ask you to think, what is the solution towards getting the infrastructure in place? And how valuable is that in terms of energy savings realized, as well as improving the indoor environment for these people living in these homes? And finally, I'd say, think about the future in air conditioning. And do we want these units having a bunch of window shakers hanging off them in 20 years? Or do we want a planned approach, particularly in low income, where there's social equity involved in this stuff? And I'll leave it at that.
Awesome. Thank you guys so much. We really appreciate the time and effort that you've put into this presentation and the work that you guys do in general. Thanks so much for putting it out there and for participating. And we look forward to continuing to learn about what you guys are developing in the future. So please come back again and tell us more.
Sure. Well, thanks for this opportunity to talk to you folks. It's always good to talk to people who are actually doing it.
Mm-hmm.
Right. I'm a researcher, and it's always important to me to sort of figure out what are the interests of people who are actually building buildings so that we do the right research.
Thank you.
Iain, we have a question about somebody wants to know what they got to do to listen to your stereo system. Do you want to plug your band right now?
I will put in I'll put an extra slide into my presentation that gets posted on your site that has links to our Bandcamp page. Yeah, you can all listen to my band. I'll put some links in the slide presentation. Is that okay?
That sounds great. I love it.
All right, I'll do that.
And I would volunteer that we have a 1-hour music video of the Building Science Boogie Band available. I think Sharon has a link. So if you would like to see the Don't Quit Your Day Job non-professional musicians, unlike Iain, do a 1-hour of music of fun of building science tunes and stuff, get that link. It's on YouTube.
Well, thanks everybody. This was so well attended. We really appreciate everybody coming out and participating and asking questions and being involved. And we look forward to seeing you all next week for part 3. Thanks, Sharon, for putting this together. You've done an excellent job. We really appreciate it. And we'll see all of you next week. Next month.
Bye, everybody.
Stay happy and healthy. Thanks, Sharon.
Yes. Take care.
Bye. Thank you.
Bye.
Okay. Where do I go?